So here we have a little whodunit. We have four suspects. Either the butler or the cook did it, unless it was the gardener or the maid. So we can write out that as either B or C or G or M. The cook didn't do it if poison wasn't used, and the butler didn't do it if it wasn't done with a revolver. Well, the thing that comes after if is the antecedent, so if it wasn't done with poison, then the cook didn't do it, and if it wasn't done with a revolver, then the butler didn't do it. If it was done with a revolver or with poison, death was swift. But death was not swift. If either R or P, then S, and it's not the case that S. And then if the gardener did it, so did the cook. If G, then C. You might want to write that if G, then G and C. But that would actually not add any content to it. Who did it then? Well, death was not swift. If death was not swift, then neither a revolver nor poison was used. So if a revolver wasn't used, the butler is cleared, and if poison wasn't used, the cook is cleared. So neither the butler nor the cook did it, so we're left with the gardener and the maid. Well, if the gardener did it, then so did the cook, but we know the cook didn't do it because we know poison wasn't used, because we know death wasn't swift. And so it must have been the maid. And it's a valid sequence, a valid argument. Now, with the primitive rules, here's a proof using just the primitive rules. Beginning with the one solid piece of information we have, that death was not swift, we then have to do a reductio of the idea that a revolver was used. We want to prove a revolver wasn't used, so we can prove the butler didn't do it. We assume R for reductio, either R or P by wedge introduction. 3 gives us the left conjunct, if either R or P, then S. So then we can prove S, but we know not S. So on line 10, we cite not S from 5, S from 9. They can't both be true, so the reductio assumption that gave rise to this inconsistency, namely R, is discharged by being denied. That gives us not R. We take the right-hand conditional from 2, if not R, then not B, and then we get not B by arrow elimination. The butler did not do it. Now we assume poison was used. If poison was used, either a revolver or poison was used, and we know that if either a revolver or poison was used, death was swift. So again, S. But S proved on 3 and 13, not S proved on 3 and 6. Now we cite not S again, 5, the S on 15, reductio of our assumption poison was used, so we get not P. Now we take the left conditional from 2, if not P then not C, and get not C by arrow elimination. The cook didn't do it. Now we have to do something irritating. We have to assume either the butler or the cook did it, use the fact that we know the butler didn't do it to show that the cook did it, and then use the fact that we know the cook didn't do it to show that neither the butler nor the cook did it. So another little reductio to prove neither B nor C. Then we can use that, which is the denial of the left disjunctive 1 and wedge elimination, to get the right disjunctive 1, which is either G or M. Now we assume for reductio again, the gardener did it. 4 tells us if the gardener did it, the cook did it. But we know the cook didn't do it. That's what 18 says. So 18 and 24, reductio, discharging the assumption on 23, G, by denying it, not G. And then on the last line, 22, either G or M, 25, not G, wedge elimination. The maid did it. So to do this proof using the primitive rules, we have to do 4 reductios. And it takes us until line 26. Now, if we have the derived rules, or some of the derived rules, we can do this a lot more swiftly and avoid the reductios. So we take not S from 3, again the one piece of information that we really have, and we take the other conjunct of 3 too. If either R or P, then S. Now we use the derived rule modus tollens, or modus tollendo tollens. When we have a conditional and we also have the denial of its consequent, so not S is the denial of S, then we can prove the denial of the antecedent. That's a 2-line rule, 5, 6, modus tollendo tollens. And if we have the derived rule De Morgan's laws, we can flip neither R nor P in one step into not R and not P. 7 De Morgans. If we take not R from 8, ampersand elimination, we can then take, if not R, then not B, the right conjunct of 2, ampersand elimination again. If not R, then not B, not R, so not B. 9 and 10, arrow elimination. The butler didn't do it. Now we prove the cook didn't do it. We take not P from 8 by ampersand elimination. And then we take the left conjunct of 2, if not P, then not C. And so we get not C. If not P, then not C, and not P, so not C. 12 and 13, arrow elimination. Now, in place of the fiddly reductio that we had to do with the primitive rules, we can put not B from 11 and not C from 14 together. Ampersand introduction. And then we flip it by De Morgan's in the other direction. Both not B and not C is equivalent to neither B nor C, 15 De Morgans. So now we get either G or M. Neither B nor C, that's the denial of the left disjunctive 1, so we get the right disjunct. 1, 16, wedge elimination. So now 1 has finally entered the assumption set. If G then C is on 4, that's a conditional. We have the denial of its consequent on 14, not C. So again, modus tollendo tollens gives us not G. 1, 2, 3. Now 4 enters the assumption set. And then on the last line of the proof, either G or M, but not G, 17, 18, wedge elimination. The maid did it. The proof with the primitive rules, 26 lines, 4 reductios. The proof with the derived rules, 19 lines, no reductios. Or rather, the reductios are sort of hidden behind the derived rule. To prove modus tollendo tollens with the primitive rules, you have to use reductio. To prove De Morgan's laws with the primitive rules, you have to use reductio. So the reductios are sort of hidden, if you like, under the derived rules. The derived rules don't allow us to prove anything we can't use with the primitive rules, but they typically shorten and simplify proofs, and in particular, they take the place of reductios.